Let's explore JavaScript arrays. Arrays are essential for storing and managing collections of data. We'll begin by looking at different ways to create them. The first method is using literal notation, where you use square brackets. An empty array is created using empty square brackets. To create an array with elements, simply include the elements separated by commas within the square brackets. Arrays can hold mixed data types such as numbers, strings, booleans, and null values. Another way to create arrays is by using the array constructor with the new keyword, followed by the word array and parentheses. You can create an empty array using new array with empty parenthesis, or you can create a fixed length array by passing the number of elements as an argument. You can also create an array with specific elements by passing them as arguments to the array constructor. The Array.from method creates a new array from an array-like or iterable object. It can create an array from a string, or it can take a mapping function to modify the elements during creation. Lastly, the spread operator can be used to create new arrays. Use the spread operator followed by an existing array to create a clone of it. Or you can use it to combine two existing arrays into a new one. Now let's explore some essential array methods in JavaScript. These methods are grouped into categories to help with different tasks. First, we'll look at methods for adding and removing elements. The push method adds elements to the end of the array. The unshift method adds elements to the beginning. The pop method removes an element from the end of the array, while the shift method removes an element from the beginning. The splice method can add or remove elements at any position within the array. Next, let's see some methods for transforming arrays. The map method transforms each element in the array and returns a new array. The filter method keeps only the elements that match a specific condition. The reduce method accumulates the values in the array into a single result. Finally, let's explore some utility methods. The slice method extracts a portion of an array and creates a new array. The concat method combines two or more arrays. The includes and index of methods are used to search for elements within an array. Let's understand sparse arrays in JavaScript. A sparse array is an array where not all indices have a corresponding value. You can create sparse arrays in a few ways. The first method uses array literals with empty slots, as shown in the code. Here we have a 1 an empty slot and a 3. Another way is by using the array constructor with a specific length, and the last way is by assigning values to specific indices while leaving others unassigned. Sparse arrays have gaps, which are empty slots, and these slots don't even contain the value undefined, even though they are empty. It is important to note that the length property may be larger than the number of elements. When using array methods with sparse arrays, it's important to be aware that the results can vary. For example, for each skips the empty slots, while map preserves the holes, and the filter removes the holes. Object.keys only includes the existing elements. It's best to avoid sparse arrays when possible. Instead, use dense arrays with explicit undefined values for more predictable behavior. Let's talk about typed arrays in JavaScript. Typed arrays provide a way to work with binary data in a more efficient manner. Different typed arrays work with different types and ranges of numerical data. Int8 array and uint8 array are used for 8-bit integers. An int8 array stores integers from -128 to 127. Uint8 array stores unsigned integers from 0 to 255. These are created using the new keyword followed by int8 array, or uint8 array constructor, and an array of integers. Int32 array and float32 array are used for storing 32-bit integers and floating point numbers, respectively. The integers range up to plus or minus 2,147,483,647. The float32 array provides a precision of 7 decimal digits. The float64 array is used for 64-bit floating point numbers, and it is the same precision as the regular number type. The use cases for typed arrays include WebGL and graphics, efficient storage of vertex data, audio processing to work with samples and waveform data, and for handling binary data such as network protocols and file formats. Now let's explore array-like objects in JavaScript. Array-like objects are objects that have a length property and support indexed access using numeric keys, but do not have access to array methods. Some common array-like objects include string objects, DOM collections, and the arguments object. String objects have a length property, and you can access individual characters by their index. DOM collections returned from methods like querySelector all also have a length and indexed access but lack array methods. The arguments object, which is available inside functions, is another example of an array-like object. It has a length property, and you can access elements by index, but it's not a true array. There are a few ways to convert these array-like objects into real arrays. You can use Array.from with array-like objects or the spread operator for iterables such as the string. You can also use the array.prototype.slice method. After converting to a real array, you get access to all array methods such as map, filter, and reduce. Let's compare array-like objects to real arrays. Both have the length property and support numeric indexing. However, array-like objects lack array methods and are not iterable by default, while real arrays have all of these features. Let's explore different methods for converting array-like objects to arrays. Array.from method can be used to convert array-like objects such as strings, or from the result of a DOM query selector, or from sets to real arrays. It also supports a mapping function, which allows you to transform elements during conversion. The spread operator can convert any iterable such as strings or sets to arrays. It can also be used to combine existing arrays. When using spread operator, a new array is created. When using Array.from method, an iterable or array-like object is converted to a real array. It is important to note that Array.from is efficient for array-like objects and iterables, and it also supports the optional mapping function. Whereas the spread operator is more concise but only works with iterables. So it is more suitable for shallow copies. It is best to prefer Array.from when converting array-like objects like DOM collections. Use the spread operator when converting simple iterables like strings, sets, or maps. For large collections, the Array.from method with mapping function is more efficient than using spread followed by map, as it avoids creating an intermediate array. Let's learn about multidimensional arrays in JavaScript. A two-dimensional array is also known as a matrix. This can be created by using nested arrays, where each element of the outer array is another array. You can access elements by using two indices. The outer index represents the row, and the inner index represents the column. To iterate over a two-dimensional array, you'll need to use nested loops. A three-dimensional array is known as a cube. It consists of arrays within arrays. You can access a particular element using three indices. The first index represents a plane, and the next two represent the row and column. You can use a helper function with nested map function to create a three-dimensional array. When working with multidimensional arrays, it's a good practice to use meaningful variable names for dimensions such as rows, columns, and depth. Some common use cases for multidimensional arrays include game boards, image processing, and representing data tables. Let's discuss performance considerations when working with JavaScript arrays. Some array operations are faster than others, and understanding these differences can help improve your code. Constant time operations, denoted as big O of 1, such as direct access using an index or adding or removing elements at the end of the array using push and pop, are the fastest and most performant operations. Operations that take linear time, denoted as big O of n, such as adding or removing elements at the beginning using unshift and shift, or adding or removing elements from the middle using splice, are slower. Also, some of the iteration methods such as the for each and map methods are linear operations. Therefore, use them cautiously with large arrays. Choose the appropriate method based on whether you need to transform, select, or find elements. You should chain methods carefully to avoid multiple iterations. Some best practices for array optimization include pre-allocation, batch operations, and using typed arrays for better performance and memory efficiency. When you pre-allocate, you initialize arrays with a known size using the array constructor. Batch operations combine multiple operations to reduce the number of modifications and iterations. Finally, use type arrays for better performance and memory efficiency for numerical data. Let's explore some common array patterns in JavaScript. These patterns can help you structure and manage data effectively. One common pattern is the map filter pattern, where you use filter to select items that satisfy some conditions and map to transform the result. You can also use the reduce method for data aggregation. Another useful pattern is the group by pattern, which can be implemented using the reduce method. Some common array manipulation patterns include removing duplicates using the set method, flattening arrays using the reduce and concat methods, and chunking arrays using the Array.from and slice methods. When you write your code, it's important to break down complex operations into meaningful steps, use appropriate method combinations for better performance, and also consider memory usage in large datasets. Use meaningful variable names for intermediate results, as it improves readability of the code. Let's look at some best practices for working with JavaScript arrays. When performing array operations, prefer to create new arrays instead of mutating the existing one. This can be done using the spread operator or the slice method. This immutable approach makes your code more predictable and easier to debug. When selecting array methods, be mindful of performance and the specific requirements of your tasks. For example, avoid multiple iterations over the array when a single iteration would suffice. Here we show a bad example of multiple iterations using filter, map and reduce, and a better approach using reduce method. Here's a quick checklist of best practices. Use typed arrays for numerical data processing, avoid sparse arrays, and use dense arrays instead. Pre-allocate arrays when you know the size, use appropriate methods for your tasks, consider memory usage when working with large datasets, and write clear, maintainable array operations. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.